everyone, welcome to the Representational Similarity Analysis Workshop. My name is Büşra Tanrıverdi, and today I will be leading this workshop for the Coding Outreach Group. Here is our brief outline. So we will start with a short introduction to what RSA is and why we use it. And then we will go over three specific tutorials with our workshop materials. And then finally, I will walk you through significance testing and share some additional resources. Okay, let's get started with our intro. RSA is a statistical technique that allows us to calculate similarity between different measures instead of directly analyzing the relationship between them. And we then compare the similarities to one another for statistical significance testing. It has become an increasingly popular technique over the last 10-15 years, especially because it is highly flexible and it allows us to link multiple sets of data. For instance, we can link neural and behavioral data together using RSA. Similarly, we can link different scales of neural data, such as from the cellular to network level. We can also do similarity analysis between different modalities of neural data. For instance, if you have fMRI and MEG data, you can use RSA to calculate how similarly things are represented between the two modalities. And finally, we can link data from different groups or species. For instance, if you want to compare young kids versus adults, or if you want to compare humans versus primates. In the workshop, we will be focusing on neural RSA and then link the RSA, the neural similarity to behavioral data. So the assumption with the neural RSA is that if two stimuli evoke a similar response in a set of voxels, it means that, or it must mean that they share something in their underlying representation, and because they are being supported by overlapping neural populations. So in this example, for instance, the two faces will be highly similar to one another, as well as the two houses, but a face to a house similarity will be much lower because they have less information that is shared between them. In a typical RSA, for the neural data, what we do is we extract either average voxel-wise patterns associated with a particular condition, such as viewing houses or viewing faces, or we can extract a trial-by-trial voxel-wise patterns. What we do is once we extract these activity patterns is that we calculate the similarity between the activity in a set of voxels, and then that will give us a representational similarity matrix that will be showing us how similarly things are represented in these voxels. So in this example here, for instance, what we are looking at is a dissimilarity matrix. And what we see here is that have this one face, for instance, in the first row is dissimilar to the other images that the participants saw. Here, because we are looking at the similarity matrix, this image is highly dissimilar to itself, which is 0. Basically, it's the same representation. And then as we move from left to right, or from cold to hot colors, we see that this image is getting increasingly dissimilar to the other images, especially the house ones. So just as a note, in the workshops that we will just start doing, we will be doing similarity analysis instead of dissimilarity because of the data that I am using. It made more sense to use similarity, but they are basically the same idea. The idea is always to see how similarly two different information is represented in the brain. So that said, let's get started with our workshop tutorials. In this workshop, we will do item or trial level RSA. We will first do one within subject example, and then we will do across subjects calculations, and then we will predict behavior from using our region-based similarity matrices.